Welcome to another class today, and in this class today we'll be looking at a new topic under the first aspect of the quantitative reasoning in GRE, that is arithmetic. And under arithmetic we'll be able to go through topics like number properties. We already went through sequence, fractions, and decimals. So today we'll be talking about a new topic called real numbers. Now, under real numbers, we're discussing real numbers. We'll talk about real number line. We'll talk about absolute values and also properties of real numbers. Okay, so without any further ado, let's get into business. Now, real numbers. What are real numbers? Real numbers include all positive and negative integers, fractions, decimals, irrational numbers including 0. So any kind of number you can think of, they are all real numbers. Positive and negative numbers, 0, fractions, decimals, irrational numbers, all of them are real numbers. All of them are real numbers. Okay, so you can say what kind of number is not a real number. Yes, we have some numbers that are not real numbers. For example, a number like square root of -4. This is not real. It's not a real number. It has no solution. It's undefined. Because you cannot find the even root of a negative number. Or maybe you're looking at fourth root of -16. This is undefined. Alright? It's undefined. We cannot find the even root of a negative number. So these numbers, they are not real. They are not real numbers. And though in mathematics there are ways we handle numbers like this, and they have their names as well, but that is not what we're looking at today. So we're talking about only real numbers. That's what you need in GRE. Alright? Now, all real numbers can be located on the real number line. Yes, all real numbers can be shown on the real number line. And what is a real number line? Now, a real number line is a straight line that is divided into equal intervals using real numbers. Okay, a straight line divided into equal intervals using real numbers. Now, as you can see in this example, this is a number line. As you can see, a straight line, and it's divided into intervals using these real numbers. That's integers. We have -3, -2, -1, 0, 1, 2, 3. So this is what we call a number line, a real number line. Now, as you can see here, we have some numbers that we have located on this number line. This is an irrational number, as you can see, and it is on the number line. This is a fraction, a negative fraction, -3/2. That's between -2 and -1, halfway between -2 and -1. Okay. This is -0.4, a negative decimal number. Alright, you can locate it on the number line. This is 1/2, a positive fraction, can be located on the number line. And we have square root of 2, which is an irrational number, can be located on the number line. A decimal number, positive decimal number, 2.6. So this is what we call a real number line. A real number line. And now, the important thing about any number line is the value of the interval. We should be able to give the value of the interval, or say what the interval is. And what do I mean by interval? I mean the difference between two successive coordinates. This is what we call coordinates. This -3, -2, -1, 0. These are the coordinates. So if you look at the difference here, that's -2. That's a positive difference. -2 -3, which will give me 1, or -1 -2. Or 0 -1, or 1 0, or 2 -1, or 3 -2. So that means the interval of this number line is 1. You are just adding 1 plus 1, you get 2, plus 1, you get 3, and so on like that. So, or -1, you get 2, -1, you get 1, -1, you get 0. So this is what we call interval. So for any number line that you see, the first is to know the interval of that number line. The interval of the number line. So now, for example, if I have a number line like this, and I can see 0, maybe 5, 10. Okay, let me say -5. So it is very obvious that the interval of this number line is what? It is 5. As you can see, the interval is 5 because you have +5, you have 10. Or If you add 5 to 0, you have 5. 5 to 5, you have 10. So meaning the interval is 5. Alright, so you can have maybe, let's say we have 0, and then we have 3, even if you have it this way. Since these 2 points are consecutive, and these are their coordinates, then the interval is 3 minus 0, which will be 3. That's the interval of the number line. So if I want to find more, all I need to do is keep adding 3. So plus 3, I have 6. Plus 3, I have 9, the next one, and so on like that. So that's one by the interval of a number line. Okay, now how can you easily find the interval of a number line? Now, the value of the interval of a number line is equal to the difference between the coordinates of any 2 points on the number line divided by the number of intervals between them. Do you get that? The value of the interval of a number line is equal to the difference between the coordinates of any 2 points on the number line divided by the number of intervals between them. So if you want to find the interval of a number line, all you need to do is look for any 2 coordinates, alright, get the difference between them, positive difference between them, and then divide the results by the number of intervals between them. Alright, so for example, if I have this number line, we have 3, 1, 2, 3. So maybe I have 18 here. And the question is asking me what is the coordinate of, so I want to find coordinates of point A. Coordinate of point A. So as it is, I may not be able to know the interval of this number line straight away. Now, what can I do? All I need to do is to find the difference between these 2 coordinates given to me. Alright, so the interval will be equal to 18 minus 3. Now, divided by, then I will count the number of intervals between this 3 and this 18. And number of intervals will be 1, 2, 3, 4, 5. So that means I have 5 intervals. So which gives me 15 over 5, and that will give me 3. So it means the interval of this number line is 3. Therefore, that means I will add 3 to this one, I get this place to be 6. Then this one plus 3, I get 9. Plus 3, I get 12, and so on like that. So if I want to find this A, I can simply just, instead of going from 3 till I get here, and I can simply just subtract 3 from 18. So 3 from 18 will give me here to be 15 as the coordinate of A. So coordinate of A will be 15. Okay, so that is how you can find the interval of a number line. Alright, let's quickly see another example. Let's say we have let me say 4. Okay, so let's say we have 19 here. Alright, so now let's say we want to find the coordinate of this point B. Coordinate of point B. Okay, so coordinate of point B. So any coordinate you are given at all, no problem. Just pick any two you can see. So now I have 4 and 19. So what do I do? So that means the interval will be equal to 19 minus 4 divided by, now how many intervals do I have? I have 1, 2, 3, 4, 5, 6. 6 intervals. So divided by 6. So this gives me 15 over 6. And when you divide 15 by 6, what do we have? We have 2.5. So that means the interval of this number line is 2.5. So to get my B, anyways, I can simply say 19 minus 2.5. That will give me 16.5. Then 16.5 minus 2.5. And that will give me 14. So meaning coordinate of B is equal to 14. Okay, so that's how you can find the interval of any number line. Once you see any 2 coordinates, subtract them, then divide the result by the number of intervals between them. Alright, now let's move on. So now we have this point that we can note. All numbers to the right of 0 on the number line are positive and greater than 0. Okay, so any number to the right of 0, they are positive numbers and they are greater than 0. So for instance, number like 1 is to the right of 0, Number like 0.1 is to the right of 0. Number like 10 is to the right of 0. So they are positive and they are greater than 0. All numbers to the left of 0 on the number line are negative and less than 0. Any number to the left, they are negative, minus 0.1, minus 0.5, minus 2, minus 5, minus 1 million, minus 10 trillion. All these numbers are negative and they are less than 0. Okay, now 0 is neither positive nor negative, so 0 is not it's not a positive number, and it is not a negative number, so it is called a neutral number. Alright, so if the question is telling you positive integers, you don't start from 0, you start from 1. Okay, 0 is not positive and it's not negative. If your real number x is to the left of your real number y on the number line, then x is less than y. For example, minus 2 is to the left of 0. So that means minus 2 is less than 0. Okay, minus 10 is to the left of minus 5 on the number line. So that means minus 10 is less than minus 5. Okay, so that's what I'm saying. If your real number z is to the right of your real number y on the number line, then z is greater than y. So for instance, 2 is to the right of 1 on the number line. So 2 is greater than 1. Okay, so minus 5 is to the right of minus 20 on the number line. So minus 5 is greater than minus 20. So that's what we are saying here. Now here, if x is less than y and z is greater than y, then x is less than y and y is less than z. Okay, so here we just showing how we can combine these two inequalities like this to give us something like this, and which easily interpret these two inequalities. Okay, so we are saying that x is less than y and z is greater than y. So here we can combine these two to form one single inequality. And what that means is this. Now, if you look at it, if I say z is greater than y, alright, if z is greater than y, then what does that mean? It means y is less than z. Okay, if z is greater than y, then y is less than z. So therefore I can say that x is less than y, which is this one. Now y is less than z. So that is combining these two. Okay, and this simply shows to me that my y is a value between x and z. Value between x and z. So for instance, I can say that minus 2 is less than 3 and 5 is greater than 3. Okay, so now if I put these two together, what will I have? I will have minus 2 is less than 3 and 3 is less than 5. Okay, so of course, as you can see, 3 is a number between minus 2 and 5. So that just helps us to interpret that easily. Okay, so if minus 2 is less than x, x is less than 4, the next is a number between minus 2 and 4, that is minus 2 and 4 not inclusive. So here we are saying that our x is between minus 2 and 4. That is, minus 2 is less than x. That means x is greater than minus 2. So if we look at numbers that are greater than minus 2, can we think of minus 1, 0, 1, 2, and the same x is less than 4. Okay, so that means you are saying that x represent numbers between minus 2 and 4. So, and if you think of those numbers, that means if you're thinking of from minus 1, for example, if your x is an integer, that is a whole number. So minus 1, 0, 1, 2, 3. Those are the numbers that can represent your x according to this statement. So your x must be greater than minus 2, but must be less than 4. So that's from minus 1 to 3 if your x is an integer. If there is no information that your x is an integer, then you have to think of all possible numbers like from minus 1.9 to maybe 3.99 and so on like that. So that is one thing you must understand here. So your x must be a number greater than minus 2 but less than 4. So that's why minus 2 and 4 are not part of the values that can represent your x. If you have something like this, minus 2 is less than or equals to x, less than or equals to 4, then your x is any number from minus 2 to 4 because of this is equal to. Can you see the difference? Here there's no equals to, so that's why it doesn't include minus 2 and 4. But now that you have equal to here, then it includes minus 2 and 4. So that means my values of x, if my x is an integer, will be minus 2, minus 1, 0, 1, 2, 3, and 4. So minus 2 and 4 inclusive. Minus 2 and 4 inclusive. Okay, so that's what you must understand here. So this equals to means it starts from here and ends here. This means it won't include minus 2, it will not include 4. Okay, so just note that. So if you don't have, if you have something like, let's say, minus 2 is less than or equals to x less than 4. What does this mean? So if your x is an integer, it means it starts from minus 2 because of this is equal to, then minus 1, 0, 1, 2, 3. So it won't get to 4 because that's equals to here. Alright, so if you have minus 2 is less than x less than or equals to 4. So this means if your x is an integer, it will not start from minus 2 because there's no is equal to here. No, so it will start from minus 1, 0, 1, 2, 3, and then 4. Okay, so that gives the values of our x. So that is one thing we have to understand here when we have this inequality statement. Okay, now we have absolute values. The absolute value of a number is the distance of the number from 0 on the number line. Alright, absolute value of a number is the distance of the number from 0 on the number line. Or if you are talking about distance, what do we mean? We are talking about number of intervals between 0 and that number on the number line. Alright, so talking about distance, now for instance, on this number line, so you have 0, 1, 2, 3, minus 1, minus 2, minus 3, let's say minus 4, okay, and also 4 here. Now, if I look at number like minus 3, okay, what is the distance of minus 3 to 0? That's the number of intervals, 1, 2, 3. That's the distance. So that's what we call absolute value. Absolute value of minus 3. So it is equal to 3. 1, 2, 3. If I look at 3 as well, for instance, what is the distance? 1, 2, 3. So distance to 0 is also 3. So absolute value of 3 is also 3. Okay, so this means minus 3 and 3, they are at the same distance from 0. So which means they must have the same absolute value. So absolute value of minus 3 is 3. Absolute value of 3 is 3. So absolute value is written like this. So when you see a number inside these two strokes, then you have what we call absolute value. So absolute value of minus 3 is equal to absolute value of 3, and that will be equal to 3. So that is one thing you must understand. So absolute value of any number is a positive value of that number. Okay, so absolute value of 5 is equal to 5. Absolute value of minus 0.1 is 0.1. Absolute value of minus 2 over 3 is 2 over 3. Absolute value of 7.5 is 7.5. So absolute value of any number is the positive value of that number. So therefore, it means that if absolute value of x is equal to 2, then x is equal to 2 or x is equal to minus 2. Alright? Because here, this x is representing a number such that if I find the absolute value of that number, I get 2. And of course, that means that number could be 2 to give me 2, or it could also be minus 2. Because absolute value of 2 will give me 2, absolute value of minus 2 will give me 2. So therefore, this x will be 2 or minus 2. That is absolute value. That's what this x will be. So this statement here is satisfied with this or this. So if you solve this, this is what we get. So x must be 2 or minus 2. That's the solution to this equation. If we have absolute value of y plus 2 is equal to 5. So this y plus 2 is representing a number such that if I put the number there, I get 5. And that number must either be 5 or minus 5. So it means y plus 2 will be equal to 5, or y plus 2 is equal to minus 5. And what does that mean? It means y will be 5. When we bring this 2 here, we have minus 2, and that will give us 5 minus 2, which is 3. Or y will be equal to minus 5. When we bring this one here, we have minus 2. So minus 5 minus 2 will give us minus 7. Okay, so this means that for this statement to be true, our y should be 3 or minus 7. And if you check, if you put 3 here, you have 3 plus 2, which will give us 5. Absolute value of 5 is 5. When you put minus 7 here, minus 7 plus 2 will give us minus 5. Absolute value of minus 5 is 5. So if you solve this equation, we get 3 or minus 7. Alright, Another example here, absolute value of x minus 7 is less than 12. So what does that mean? This means this x minus 7 must be less than 12. Don't forget this inequality. So it must be less than 12, or x minus 7 will be greater than minus 12. Can you note that? Okay, so when you have inequality, it's right from equations. When you have inequality like this, and you are turning this to minus 12, okay, minus 12, that's you are multiplying it by minus, all right, by minus 1. So this sign must reverse. Is a rule under inequality. When you multiply both sides by a negative number, or you divide both sides by a negative number, the inequality sign will turn. It will be reversed. So x minus 7 is less than 12, or x minus 7 is greater than minus 12. So if we solve this, we have x is less than 12 plus 7, or x is greater than minus 12 then plus 7. So this means our x will be 12 plus 7 is less than 12 plus 7 means x is less than 19, or x is greater than minus 12 plus 7, and that means x is greater than minus 5. And what does this mean? It means that minus 5 is less than x, and the same x is less than 19. Remember how to combine them. So which gives us this? Means minus 5 is less than x is less than 19. That means x must be a value between minus 5 and 19 for this statement to be true. Alright, so and if you can check some values, that means you're talking about values from minus 4, minus 3, minus 2, down to 18 if your x is an integer. Okay, if x is an integer. So minus 4 to 18. And if you check, let's say we try with minus 4. Minus 4 minus 7 will give us minus 11. Absolute value of minus 11 is 11, which is less than 12. If you check with 18, which is the highest integer there, that will be 18 minus 7, which will give us 11. And the absolute value of 11 is 11, which is less than 12. So you can try another number. Maybe you pick 0, because 0 is also among them. 0 minus 7 is minus 7. Absolute value of minus 7 is 7, which is less than 12. So this satisfies this inequality. Okay, so when we solve this, this is what we have. So any value in this range can be our x, can be part of our answers. Okay, so that is how we simplify absolute value equations or inequalities. All right, so now we have these properties of real numbers that you can note to help you answer your questions faster. Okay, now if x is greater than 0, then x is positive. Anything greater than 0 is when you see this statement, that's really telling you that x is a positive number. For any number to be positive, it must be greater than 0. 2, if x is less than 0, then x is negative. Anything less than 0 is negative. It's negative. If xy is less than 0, then x and y have different signs. Xy means x times y. So I'm multiplying two numbers to get something negative. That can only happen when the two numbers have different signs. That is when one is positive and the other is negative, because it is plus times minus or minus times plus that will give you a negative result. So this statement simply tells you that one of these x now y is positive and the other one is negative. That's what this statement is saying. Okay. Another point says if xy is greater than 0, then x and y have the same sign, both positive or both negative, of course, because plus times plus will give you plus, minus times minus will give you plus. So if you multiply two numbers and you are getting a positive result, then those two numbers must be of the same sign. They must be both positive or both negative. So that's one thing you can say about this statement. If xy is equal to 0, then x is equal to 0, or y is equal to 0, or both x and y are zeros. What does that mean? It means you're multiplying two numbers to get 0. And for you to multiply numbers and get 0, it means at least one of those numbers is 0. Even if you have 1 billion numbers, if you multiply them and you get 0 as your result, then at least one of those numbers, at least one, is 0. So if at least one is 0, the result will be 0 definitely. So it's here means x is either 0, or maybe y is the one that is 0, or maybe two of them are even zeros. So it could be 0, 0. So that's what this statement is telling us. Once the product gives us 0, then at least one of the numbers is 0. Next one says if xy is equal to xz, then y is equal to z. Of course, we have x, x. So we can see x is common to both sides. You can divide both sides by x. So x eliminates x, then we can have y is equal to z. If x is less than 0, then x raised to power a is positive if a is even, or x raised to power a is negative if a is odd. Okay, so here we're talking about a negative number. When our x is negative, then if you raise it to an even power, the result is positive, always. But if you raise it to an odd power, the result is negative. The result is negative. So, for instance, what we are saying is, if we have, let's say, minus 2 raised to power 4, minus 2 raised to power 4 will give us 16. Positive result. Because this minus also means raised to power 4. So when you raise minus to an even power, it turns positive. But if you have minus 2 raised to power 5, this gives us minus 32. Yes, when you raise minus to an odd power, it remains minus. Okay, so if you have a negative number and you raise it to an even power, you get a positive result. But if you raise it to an odd power, you get a negative result. That's what we are trying to say in that statement. Alright, so another one says, if xy is less than xz, then y is less than z if x is positive, or y is greater than z if x is negative. Can you notice that? So here we have inequality. It's different from this equation. Alright, in this one we can simply cancel x and then y is equal to z. But here this is an inequality. We have to be very careful when we say, because it's easy to see this and say, okay, x cancels x, so y is less than z. But that may not be the right answer. And why is because the x, we have to be sure what kind of number it is. If our x is positive and we divide both sides by x, our sign remains the same, then y will be less than z. But if your x is a negative number and you are dividing both sides by x, remember when you divide both sides by a negative number in inequality, the inequality sign must be reversed. So that means if x is negative and we divide both sides by x, then our answer becomes y is greater than z. So that's why when we see a question like this, we have to be very careful before you can answer it. Don't just jump to it. Okay, so for instance, you can have something like this in GRE. Maybe you have p q raised to power 3 is greater than r q raised to power 3. And the question says quantity A, P, quantity B, R. Okay, now if you check this out, you will see that, okay, we have q raised to power 3 on both sides. So we can then say q raised to power 3 eliminates q raised to power 3. So our P is greater than R. But I tell you, that may not be correct. And why is because this q, we are not sure if q is positive or negative. So because if q is positive, then q raised to power 3 is positive. Alright? Because when your number is a positive number, if you raise it to any power, either odd or even, it remains positive once the number is positive. Alright? So if q raised to power 3 is positive, then we can simply say that, okay, we divide both sides by q raised to power 3, and then that means our p will be greater than r. And that is telling us option A. Okay, greater A, quantity A greater. But what if our q is negative? Because we are not sure, there's no information. So that means our q raised to power 3 will be negative. Remember, when you raise a negative number to an odd power, the result is negative. So in that case, by the time we divide both sides by q raised to power 3, we are dividing by a negative number, so the sign must be reversed. So we should have p is less than r. P is less than r, telling you b now greater. So as you can see here, it is obvious this cannot be determined. So our answer will be D. Okay, so we have to be very careful with this kind of question. Okay, but let's say we have something like this. P q squared is greater than r q squared. So quantity A, P, quantity B, R. Alright, so here this is very clear. Why? Because the power on Q is even power. Okay, so either Q is positive or negative. when you raise it to an even power, you get a positive result. So our q squared is always going to be positive. So it's going to be positive. That's very clear. It's always going to be always positive. So if it is that, then we can easily say, fine, this is this, and this eliminates this. Therefore, Rp is greater than R. So definitely, quantity A is greater. That's it. It is greater. So that is one thing you should understand there. So just check the power. Just check the power. That helps to understand this easily. Okay. Now the next one says, if W over X is less than Y over Z, then X over W is greater than Z over Y. Alright, so this simply is just talking about fractions. So that is when you turn your fractions to the reciprocals, the inequality sign must be reversed. So if you have W over X is less than Y over Z, and you now turn it to X over W, then it must be greater than Z over Y. Greater than Z over Y. Right, so that is what that point is saying. Like, for example, 1 over 3 is less than 1 over 2. So therefore, 3 over 1 must be greater than 2 over 1. Okay, that's simply what we are talking about there. Right. Now, another one says absolute value of X is equal to square root of X squared. Yeah, absolute value of X is something as square root of X squared. So absolute value of 5, same as square root of 5 squared. Absolute value of minus 5, same as square root of minus 5 squared. Okay, so absolute value of X times absolute value of Y is equal to absolute value of X times Y. Yeah, absolute value of 2 times absolute value of 3 is equal to absolute value of 2 times 3. Absolute value of minus 2 times absolute value of 3 is equal to absolute value of minus 2 times 3. You can just check it, it gives you the same answer. I can put numbers there to verify that. Absolute value of X plus Y is less than or equal to absolute value of X plus absolute value of Y. Right? So you can put numbers and verify this. So you always get something less than this or equal to it. So less than or equal to S, absolute value of X plus Y. So these are some properties you can note that will help us answer our questions very fast in the exam situation. Okay, now let's check out some standard examples here and see how we apply some of these points to answer our questions. Okay, now question 1, quickly. It says R over T is greater than 1.354. Now quantity A, T over R, quantity B, 0.75. Okay, so here, what can you notice? R over T. Now quantity A is saying T over R. So they are just giving you a fraction and they want you to do the reciprocal. So what point can we use here? Of course, you should remember this point here. So when you turn it to reciprocal, the sign must reverse. So that's just the idea we'll use to answer that question very fast. So here it says R over T is greater than 1.354. So now T over R and then 0.75. So you can now use that property and try the question by yourself. You can pause the video, try it, and see what the result will be. And then you can check the solutions. Okay, so now let's see the solution to this question. So now I can write this as R over T is greater than 1.354 over 1. Now they're asking me T over R. That's the reciprocal of this, remember? So the sign must reverse to less than. And I have 1 over 1.354. And when you check with your calculator, then you divide 1 by 1.354. What does it give you? You get less than 0.737 whatever. Okay, so our T over R is less than, even if I approximate 0.74. Okay, so T over R is less than 0.74. And we are comparing with 0.75. So if T over R can be less than 0.74 and 0.74 is less than 0.75, then automatically T over R is less than 0.75. So meaning B is greater here. So quantity B will be our right answer. Yeah, that's it. That's how you solve that. And you can just do that in 30 seconds and you're good. Alright. Now example 2 says X is greater than Y. Quantity A, absolute value of X plus Y. Quantity B, absolute value of x minus y. Okay, your x is greater than y. A, absolute value of x plus y. B, absolute value of x minus y. Yeah, so something like this, you can just put in some numbers to check if A is greater than B or B is greater than A, or if they will always be equal. We're looking for the one that will always be, no matter the numbers you use. Maybe always A will always be greater than B, or B will always be greater than A, or maybe they will always be equal, or maybe you cannot determine it. Okay, so let's check what this will look like. So best thing we can do here is to pick numbers. Pick a number for your x, pick a number for your y. You can pick any number, positive, negative, 0, fractions, decimals, no problem, because there is no information at all apart from x is greater than y. So I can say, for instance, 2 is greater than 1. So this is my x, this is my y. So therefore, I will have my A will then be 2 plus 1, which will give me a total of 3, and that will be 3. Then B will be 2 minus 1, absolute value of 1, which will give me 1. So what is this telling me? It's telling me that my A is greater than B. So that's telling me option A. But without the final answer, no, you cannot conclude yet. You have to try another 2 numbers. And if I were you, I'll pick another number apart from positive. Maybe 1 positive and 1 0. So let's say I do 1 and 0. What about that? Yes, I can pick 0 too. So maybe x, y. And that means my A will be 1 plus 0, giving me absolute value of 1, and that is 1. And for B, what do I have? 1 minus 0, that gives absolute value of 1, which is 1. Oh, now this one is saying they are equal. That is C. So what does that mean? It means this cannot be determined. Our answer will be D. Okay, so it's cool. Since you used 2 positive numbers first, the next one you want to try, use one will be a positive and a 0, or negative and 0, or 2 negative numbers, or 1 positive, 1 negative. So don't pick two positive numbers all the time. Alright, so that will help you to see if you're going to be getting the same answer or it will not be determined. Okay, now example 3 says, if absolute value of z is less than or equals to 1, which of the following statements must be true? Indicate all such statements. Absolute value of z is less than or equals to 1. Which of the following statements must be true? Indicate all such statements. So we have some options here. Just don't bother yourself with that error. Just follow the options like that, A, C, and D. So A says z squared is less than or equals to 1. C, z squared is less than or equals to z. D, z raised to power 3 is less than or equals to z. So which of the following statements must be true according to this information? Alright, so let's look at the solution to this. Now, from the information, let's interpret that first so that I can see the possible values of our z. So, if you have z is less than or equals to 1, like we explained, what does that mean? That means z is less than or equals to 1, or z is greater than or equals to minus 1. Remember, when you want to write the minus, you reverse the sign. Minus 1. So minus 1 is less than or equals to z, less than or equals to 1. So this means our z will be any number from minus 1 to 1. And don't forget, the question has not said our z is an integer. So it can be any number. So I have to think of possible numbers. So let me just pick some numbers. Minus 1 definitely, yeah. Okay. Then there will be a negative decimal number. So which is going to be definitely 0 point something, because we are talking about between minus 1 and 1. So let's say negative 0.5. Then 0 will be there. Positive 0.5. And then 1. So these ones represent our values. Alright, so let's now see which of these 3 will be true with all these positive values. Yes, we have to test with all to be sure that it will always be true. That's because it must be true. Like anytime, any day, with any of these values, it will always be true. So option A says x squared is less than or equals to 1. So now, if my z is minus 1, so minus 1 squared will give me 1, which is equal to 1. So that is true. Minus 0.5 squared, let me turn it to a fraction, minus half squared, which is 1 over 4. 1 over 4 less than 1, true. 0 squared, of course, will give us 0, true. 0.5 squared, of course, that's also 1 over 4, true. 1 squared, of course, is equal to 1. True. So definitely our A will always be true. A will always be true. Now, if you look at the second option, B, Z squared is less than or equals to Z. Okay? Now, if our Z is minus 1, so minus 1 squared will give me what? Will give me 1. Now, 1, is it less than? Don't forget my Z is minus 1. Okay? Now, if I square and I get and Z squared is equal to 1, so is 1 equal to minus 1? No. Is 1 less than minus 1? No. So that means this B is completely out. We don't need to bother ourselves with the remaining numbers. Since the first one is not even true with it, then we forget it. Now, to our C says Z cube is less than or equals to Z. Okay, cool. Now, if we pick minus 1 raised to power 3, it will give us minus 1, which is equal to Z minus 1. So it's true for minus 1. What about minus 0.5? So minus 0.5 raised to power 3. If you turn it to a fraction, that is minus 1 over 2 raised to power 3, which will give me minus 1 over 8. Now, minus 1 over 8, is it less than minus 1 over 2? Our Z is minus 1 over 2. We are checking as minus 0.5. So, is minus 1 over 8 less than minus 1 over 2? That's what we are checking. Now, is it less or not? You can check. Now, how do you check this? Let me show. For us to compare these two fractions, because they are negative, it may be difficult a bit. What you can do is this. Remove their minuses. Compare them as positive numbers. 1 over 8 and 1 over 2. Which one is bigger? Remember, from our fraction, they have the same numerator. So compare the denominator. So the bigger the denominator, the smaller the fraction. Okay? Now that 8 is bigger than 2, then that means 1 over 8 is less than 1 over 2. Now, if 1 over 8 is less than 1 over 2 as positive numbers, now when they become negative, the bigger one now becomes the smaller, and the smaller becomes the bigger. So the smaller when they are positive becomes the bigger when they are negative. So now, in that case, if you bring minus, then minus 1 over 8 must be greater than minus 1 over 2. Yes, minus 1 over 8 must be greater than minus 1 over 2. So, and this one is telling us that less, which is not true. It's not true. That's not true. So, with this minus 0.5, this one also will not be true. That shows A only will be our answer. Only A will be our answer for this question. Alright? Now question 4. If absolute value of t plus 3 is greater than 5, which of the following could be the value of t? Indicate all such values. Alright? So, absolute value of t plus 3 is greater than 5. That's what the question is asking us. So, which of the following could be the value of t? Could be the value of t. So, indicate all. So, remember you have to speak all the positive and possible answers. Alright, so you have minus 9 as your first, B, you have minus 6, C, you have minus 2, D, you have 0, E, you have 2, and then F, you have 3. Okay, and so, how do we do this? Remember how we interpreted this in our explanation. So, now, that means you can try it looking at the explanation we did previously and pause the video, do this question, pick your answer, and then check for the solution. Okay, so now we have this as a solution. So now, remember this will be, if we have this, then this becomes t plus 3 is greater than 5, or t plus 3 is less than minus 5. So what does that mean? It means t is greater than 5. Bring this one to the other side. You have, that's to this side, you have minus 3. That means t is greater than 2. Or we have t to be less than minus 5. So this comes to this side, we have minus 3. That means t is less than minus 8. So our t is greater than 2 or less than minus 8. So remember that combining them. So check your options here. which of these numbers is greater than 2? First, I have 3. Another one, no. Then which of them is less than -8? That must be to the left of -8. And that must be what? -9. Another one, no. So that means our answer should be A and F. That's your answer, A and F. Alright? Okay, now let's see this last question. It says points A, B, C, D are on the number line above. That's this number line. And AB is equal to CD is equal to 1/3 of BC. So what is the coordinate of C? What is the coordinate of this point C? So we have a number line here. And we have AB to be equal to CD equal to 1/3 of BC. So what is the coordinate of this point C? What's the coordinate of this point C? Now, remember what we talked about on that number line. First thing is to know the interval. If you don't know the interval of this number line, we cannot even get the coordinate. So you have to get the interval first. And to find the interval, remember, we find the difference between these two coordinates we can see here. And we divide by the number of intervals between them. But how many intervals are between them? That's the question here. Because you can see A, B, C, D. Yeah, they look like they are correct. But B to C, that's not looking like a normal interval. But they have given us an information here. So your AB must equal to CD and must equal to 1/3 of BC. And 1/3 of BC means what? Divide BC into 3 equal parts. Alright? So now, what will be the solution to this? So let's look at the question. Okay, so now in this question now, so we first look at this. So AB is equal to CD is equal to 1/3 of BC. Like I said, it means AB same as CD and 1/3 of B and C, meaning that we need to divide our BC into 3 equal parts. And what does that mean? So you can do something like this. Just try gauge it very well. So we have something like this. So we have divided our BC to 1, 2, 3 intervals. So now AB same as CD same as 1 of BC. That means we have normal intervals now. Alright, so what does that mean? That means between A and D we have 1, 2, 3, 4, 5 intervals. 5 intervals. Now to get the interval of the number line, so interval will be the difference between these two coordinates minus 1/2 minus 1/3 divided by the number of intervals between them. That's 1, 2, 3, 4, 5. So we have 5 intervals divided by 5. And this gives us, remember from our fraction, so when you have this, that will be 3 minus 2. That will give us 1 over 3 times 2, which will give us 6 over 5. So that is 1/6 times 1/5, which gives us 1/30. That is the interval of this number line, 1/30. So it means we add 1/30 to 1/3 to get point B, add 1/30 to point B to get the next, and so on. So now we want to find coordinates of C. Coordinate of C, that is this point here, this point. And so what do? We can simply just subtract 1/30 from 1/2 to give us coordinate of C. And that 1/2 minus 1/30. And then C will be 30, and that will 2 in 30 is 15. 50 times 1, we have 15, minus 13 30 is 1. 1 times 1, we have 1. So 14/30. And if we simplify this, divide by 2 by 2, that means we're going to have 7/15 as the coordinate of point C, 7/15. So that's what will be the answer to that question. So that will be option what? Yeah, that's option D, 7/15, option D. Okay, so that's coordinate of point C. And with that, we've come to the end of today's class. Like I always say, I advise you go through the videos again, watch through again, and then check through the questions and the examples and try to practice more questions. That will make you better. The more questions you practice, the better you become in GRE, and the higher your score becomes. Okay, so that's the class today, and I will see you in the next class. Make sure you don't miss that. Take care. Bye.